Assalamu alaikum. Welcome to my YouTube channel. Let's start our today's lecture. In the previous lecture, we discussed move, add, and sub instruction, the basic structure of an assembly program, and discussed how to code, debug, and run an assembly program. In this lecture, we are going to discuss labels in assembly language, data types in assembly, declaration of labels, implementation of labels in program, and listing file of previous program. Let's begin. Labels are variables in assembly language that refer to the symbolic name of some memory location. In short, we can say that labels are name of some memory location. Why they are used? They are used for the following purposes: to reference specific points in the code or data. We can understand this point with the help of an example. Let's consider there is a class of 10 students. The teacher wants to communicate with a specific student. So how she will communicate with that student? She will call him her by her name, and the student will respond to the teacher. Same is the role of labels is in the code. For branching instructions are the instructions that alter the flow of execution of a program based on a certain condition and jump to the specific part referenced by the label. The third purpose is to indicate the start of a subroutine function or section of the code. It is just like calling a specific student in class. Let's discuss data types in assembly. In assembly, we have 4 data types based on the size of data they can hold. The first data type is byte, which is of 8 bits and it is denoted by dB. Next we have word, which is of 16 bits and is denoted by DW. Then we have double word, which is of 32 bits and is denoted by DD. Then we have quad word, which is of 64 bits and is denoted by DQ. Most commonly we will be using byte and word. Let's see declaration of labels. What are labels? Labels are name of memory locations. So let's see its syntax. For declaration of a label, we just have to write label name and then write colon after it. Let's see an example. We have example number colon. Here number is the label name. Let's see syntax for declaration and initialization at same time. For storing a single value label, we just have to write the label name colon data type data. Let's see an example. We have label num colon db5, where num is the label name, db is the data type byte, and 5 is the value to be stored. For storing multiple values in label, we can have two syntax. The first one is label name data type data1 data2. Let's see an example. We have num colon dw 5 10 15 20. Here num is the label name, dw is the data type word for 5 10 15 20. The next syntax is label name data type data1 data type data2 and so on. Let's see example num db5 db10. What's the difference in both syntax? In the first syntax we have written the data type once, while in the syntax 2 we are writing data type with each data separately. Both syntax can be used, but I will prefer the first one as we have to write data type once. So let's move to our next slide. A simple program implementing the concept of label. Let's understand the program first. Originate 0x100 is indicating the start of program. Then we have instruction move ax num1. It means we are moving the content of num1 to ax. When you see a label name and square braces around the label name, it means we are moving the content of that memory location to the destination. I hope you understood. So move ax num1 is moving the content of num1 or the content stored at memory location num1 to destination ax. Then we have move bx num2. We are moving the content of num2 to bx. Then add ax bx. Here we are adding the content of num1 and num2. As data stored in these registers is the data stored at num1 and num2. Then we have move bx num3. We are moving the value stored at num3 to bx. Then add ax bx. We are adding bx and ax. Then we have the instruction move num4, comma ax. Here it means we are moving the data stored at ax to the memory location num4. Then we have instruct termination instructions move ax0 x4 to 0 int 0 x21, where the program is terminated. Here is the point to note that we often declare variables after the termination statement because the control never comes after the termination statement. So here we have declared num1 colon dw5. Here we are following the first syntax we learned, that was label name data type value. So here we have 4 labels. Num1 is storing 5 of word data type, num2 is storing 10 of word data type, num3 is storing 15 of word data type, and num4 is storing 0 of word data type. Now let's move again to our program and see the calculations. At num1 we have value 5, so 5 is moved to ax. At num2 we have 10. So 10 is moved to bx. Add ax, bx will generate result 15. That is f in hexa, so f will be stored in ax. Then we have move bx num3. At num3 we have 15. So 15 will be moved to bx, which is f in hexa. Add ax, bx. Now we have f in bx and f in ax. So 15 plus 15 will generate 30. The hexa value of 30 is 1e, which will be stored in ax. The result stored in ax will be moved to the memory location num4. Here we have 0 to 0 will be replaced by value 1e. Then we have termination statement, the program will be terminated. So now let's see implementation of this program in DOSBox. So let's open Notepad, create a new file. I am just copying the code I have already written and pasting there. Let's add some space. This is start of code, this is end of code, and here we are declaring the labels. Let's save the file by pressing Ctrl S. Let's name it second.asm and hit save. So file is saved. Now let's open DOSBox. I am going to set DOSBox as emulator for assembly. We are now in drive C, so we can run the code. Before running, we have to create an executable file as well as a listing file. Let's create nasm second.asm -o second.com -l second.lst. -o second.com for executable file and -l second.lst for creating a listing file. Let's press enter. The statement is executed without showing any error, so it means that our code is error free. Let's debug it. We will type aft second.com. So we are in the debugger. Here we can see that num1 is replaced as 0117. Actually in memory, num1 is the memory address which is 0117. So we are moving the value stored at 0117 to ax in the first instruction. So by executing move ax 0117, we must have 5 in ax. So let's see. We can see that 5 is moved to ax. The next instruction is move bx 0119. 0119 is the memory address of the next value, that is 10. So 10 must be moved to bx. 10 is moved to bx. Now we have instruction add ax bx. It means 5 and 10 will be added and the result will be updated in ax. So we must have f in ax. So we have a f in ax. Now we have the instruction move bx 011b. 011b is a memory address of num3, which is storing value f. So f must be moved to bx. F is moved to bx. Now we have instruction add ax bx. So add ax bx will generate 30, which is 1e in hexadecimal. So ax must be updated as 1e. We can see that in ax we have 1e. Now in the instruction we are moving the result, that is 1e, which is currently stored in ax, to num4, which is 011d in memory. So let's execute. The result of ax is moved to num4. Now we have the termination statement and the program is terminated. To return back to DOS interface, we have to type quit and then press enter. So we are back at our interface. Now to see the listing file, we have to type and the name of listing file, that is second.lst. Now we can view the listing file. The listing file is a type of file that provides us a detailed information about our code, and the coders use it for determining the efficiency of their program. So let's see. Listing file generally shows the opcode, the byte address, and our source code. At the right side we have the source code, at the left side we have the byte address or bytecode, or in center we have opcode or machine code, or we can say the code we have viewed in the debugger. So let's see. Originate from 100, it simply means start from 100 line, so there is no opcode or byte address for it. Then we have at line number 3, we have the byte address starting from 0. Then we have the opcode A1 1700. 1700 is the memory location. Then we have the source code move AX num1. In the line 4 we have 7 times 0 then 3. And then we have the opcode, and then we have the source code move VX num2. Now there is a point to note why there is 3. because the opcode in line 3 is taking 3 bytes. How we can know? A and 1 are making 1 byte, 1 7 are taking 1 byte, and 0 0 are taking 1 byte. Because in opcode we have 6 characters, each character takes 1 nibble, that is equal to 4 bits. A1 are combined to form a byte, 1 7 are combined to form a byte, and 0 0 are combined to form a byte. So the opcode in the line number 3 is taking 3 bytes, that's why the next address is starting from 3. Similarly, at line number 4, the opcode is taking 4 bytes. So 3 plus 4 is equal to 7, so next address is starting from 7. I hope you understood. The opcode at line number 5 is taking 2 bytes, so 7 plus 2 is equal to 9, so next address is starting from 9. At line number 6, the opcode is taking 4 bytes, so 9 plus 4 is equal to 13, which is D in hexadecimal, so next address is starting from D. At line number 7, opcode is taking 2 bytes, so D plus 2 is equal to 15, which is F in hexadecimal, so the next address is starting from F. I hope you understood. Now we can see the termination statement. The code for termination statement is fixed. After the termination statements, we can see that we have the code for declaration of labels. So at the left side, we have the bytecode. In the center, we have the values that are stored on these locations. And then we have the source code at right side. I hope you all understood. Let's discuss some more examples that are implementing the concept of labels for our better understanding. Now we have program number 2, where we are implementing the other syntax of declaration and initialization at the same time. Originate from 100 line is indicating the start of program. Move AX num1. Here we are moving the value of num1 to AX, which is 5. So 5 will be moved to AX. Then we have the instruction move BX num1 plus 2. Now what's the change? Now a single variable num1 is storing different values. To access the other values, as the data type is word, so we have to add 2 bytes to access the next value. That's why we are using num1 as an initial location and adding plus 2 for accessing the next values. So num1 plus 2 will move 10 to bx. Then we have instruction add ax bx. It means 5 and 10 will be added and the result will be stored in ax, which will be f or 15. Then we have instruction move bx num1 plus 4. Now we are adding 4 bytes. It means we are, by adding 2 we can get 10, by then adding 2 we can have the value 15. So we are accessing the value 15, so 15 will be moved to bx. Then we have the instruction add ax bx. It means we are adding 15 to 5 plus 10, that is 15, so result will be 30, which will be 1 in hexadecimal and will be stored in ax, as ax is the destination. Then we have move num1 plus num1 plus 6 comma ax. Here we are storing the result in num4. By num4 I mean at the 4th location, that is after 15. Then we have the termination statement and the program will be terminated. We will see the implementation of this code in the next lecture, and we will discuss program number 3, and then I will have an assignment for you in the next lecture. I hope you all understood. Thank you.